Today, we are going to tackle what is probably the single biggest hurdle for anyone learning to code. And here's a hint. It has nothing to do with syntax. It's all about a massive shift in how you think. We're going to break down how you can go from just writing code to actually solving problems with it. So let's just dive right in.
So, does this look familiar? You've spent hours, maybe weeks on tutorials. You know your for loops, your functions, your variables, but then you face a blank screen with a real problem and you just freeze. If that's you, you're not alone. This is the wall that pretty much every new developer hits, and today we're all about breaking through it.
This quote right here, it gets to the absolute heart of everything. You see, expert programmers know that the solution isn't found by just hammering away at the keyboard. No. The real work happens way before a single line of code is ever typed. And that brings us to the fundamental shift. You have to stop thinking of programming as just telling a computer what to do. You need to start seeing it for what it truly is, a problem-solving discipline. Seriously, this change in perspective is what separates a beginner from a professional. This right here lays out that mental shift perfectly. See, over on the left, the learner is totally focused on the tools and the syntax. They're asking, how do I write this? But look to the right. The programmer, they're focused on logic and process. They're asking a totally different question. What am I actually trying to solve? It's a huge move from worrying about the tools to defining the strategy.
And this is the big picture, you know? Every single app on your phone started as an answer to a question. Gmail asked, hey, how can we make email way simpler? Social media apps asked, how can we connect with our friends easier? At their core, they're all just really elegant solutions written in code.
Okay, so let's get practical. Step one, way before you even think about your code editor, is to deconstruct the problem. This is those 55 minutes from the quote we saw earlier. This is the time you spend really understanding the challenge, inside and out. So how do you actually do that? Well, first, you've got to restate the problem in your own words. It sounds simple, but it forces you to be clear. Second, ask a ton of questions. Expose all your assumptions. What are the inputs, the outputs, what are the limits? And third, you have to work through some actual examples. This makes the abstract problem real and tangible.
And this leads us to a classic and kind of funny technique, rubber duck debugging. The idea is super simple. Explain your problem line by line, out loud, to something like a rubber duck. I know, it sounds weird, but the act of forcing yourself to say the logic out loud is often all it takes to make you go, oh, wait a minute, and see the flaw yourself.
All right, so once you've really deeply understood the problem, now it's time to build your blueprint. This is where you move from analyzing the what to actually outlining the how.
Now, this process is absolutely critical. Don't just jump on the first idea that pops into your head. First, brainstorm a few different approaches. Second, weigh their pros and cons. Is one faster? Does one use less memory? And third, write out your chosen plan in pseudocode. And that's just a fancy way of saying write the steps down in plain English, totally ignoring the syntax of any programming language.
And when you're brainstorming, you've got to dig deeper than that first gut reaction. Really challenge that initial brute force idea. You need to define what optimal actually means for this specific problem. Is it pure speed, or is it about saving memory? This brings you to that classic space-time trade-off. You know, where making your code faster often means using more memory. Thinking through these things is what makes a solution truly great, not just good.
Only after all of that planning, after all that thinking, are you finally ready to write code. And even then, it's not about just typing it all out at once. It's a cycle of building a little and then checking your work. A really disciplined way to do this is called test-driven development, or the red-green refactor cycle. So here's how it works. First, you write a test that you know is going to fail. That's red. Then you write the absolute simplest, bare minimum code to make that test pass. That's green. And finally, you refactor. You clean up and improve the code you just wrote. It's a powerful little loop that makes sure you're always building on solid working code.
And you know, this is a huge mental win. Don't try to write the most perfect, elegant code right out of the gate. Just aim for a working prototype. Getting something, anything to work, even if it's messy, it builds so much momentum and confidence. It's way easier to improve code that already works than it is to write perfect code from scratch.
Okay, and here is a super crucial step to do before you even run your program. Become a human debugger. Seriously. Take one of those examples you came up with earlier and mentally walk through your code line by line. Pretend you're the computer. Track your variables. See if the logic actually does what you think it does.
This one little practice will help you catch so many errors before they even happen. So we have the method, we have the steps, but to make it all second nature, you need to cultivate the right mindset. This isn't just about the steps you take. It's about how your brain is wired to approach problems in the first place. This slide illustrates a really key idea called thinking fast and slow. So let's look at this puzzle. A bat and a ball cost $1.10. The bat costs exactly $1 more than the ball. Now, our fast, instinctual brain immediately shouts, "The ball is 10 cents!" But wait, slow down. If the ball is 10 cents and the bat is $1 more, the bat would be $1.10, which makes the total $1.20. That's wrong. You have to engage your slow, analytical brain to realize, aha, the ball is 5 cents and the bat is $1.05. Programming demands that you use that slow, deliberate, logical part of your mind all the time. Great programmers also get that they don't have to reinvent the wheel for everything. Just like Isaac Newton built on the work of others, you can and you should build on existing libraries, frameworks, and solutions. Know what tools are out there. Your real job is to solve the problem, not to build every single piece from the ground up. And finally, you have to be adaptable. As the great Bruce Lee said, become water. The tech world is always changing. The specific language or framework you love today might be old news in 5 years. But the core principles of problem solving, of breaking things down, of planning, of testing, those things are timeless. Master the principles, not just the tools. So if you take one thing away from this today, let it be this. Thinking like a programmer is not some magical talent you're either born with or you're not. It is a skill. It's a mental muscle that you have to strengthen through deliberate, rigorous, and regular practice of these exact methods. So I'm going to leave you with this question. Forget about writing code for just a second. Think about a problem, any problem at all, big or small, that you want to solve. Using the framework we've just talked about today, what problem are you going to break down first?